Good morning, everyone. Today we're going to learn about exponential functions and how do we graph them. What are the concepts of growth and decay? So an exponential function is an equation in the form y equals a times b to the x. The b is your base. The x will always be an exponent. So when you're writing these equations, you will always have an x there. So like y equals 5 to the x. You will see these situations in real life because let's say I send a text message to 5 of my friends and they forward that text message on to 5 more people. And those 5 people send it on to 5 more people. Rumors are a typical thing that grow exponentially, right? If you tell something to somebody, then eventually it gets around the whole school. So when you're graphing an exponential function, there's an asymptote. And that's an imaginary line that the graph never crosses. We show its existence by dashing the line. So if I were going to graph my y equals 5 to the x, exponential functions take this shape. The asymptote would be a line like this to where the graph never goes below that line. Okay? There are 2 types of exponential functions. The first one is a growth function. That's when your base is bigger than 1. So y equals 2 to the x, y equals 3 to the x, y equals 4 to the x. Okay? The parent function that all the other graphs are based off of for a growth is just y equals 2 to the x. Things are doubling. So you could take the x values from -3 to 3 and plug it in. So 2 to the -3, 2 to the -2, 2 to the -1, 2 to the 0, 2 to the first, 2 to the second, 2 to the third. Evaluate those and see what your answers are. Or if you're using a graphing calculator, you can graph these. Go to y equals. Type in 2 to the x. If I hit the graph button, it'll show me what the picture looks like that I need to make. Right above the graph button where it says table in blue, if you hit second graph, it'll take you to the table. And you can go up and down in the table and write down your values and then plot those points. So I need a table from -3 to 3. If I write that on my paper, I have 0.125, 0.25, 0.5, anything to the 0 is 1, 2 to the first is 2, 2 squared is 4, 2 to the third is 8. Okay? So plot those points. At -3, I'm at 0.125, -2, 0.25, -1.5, 0, 1, 1, 2, 2, 4, and 3, 8. So my graph is looking like this. It's growing. This graph has an asymptote. If you look at this graph on the picture, this graph never goes below the x-axis. So there's like an imaginary line here that says this is the cutoff point for the graph. It won't go below this point. Okay? So when I do an exponential decay function, my graph should be going downward. It's getting smaller. It's decaying. Its parent is y equals 1/2 to the x. If we type this in our calculator, y equals 1/2 to the x. If you look at this picture, the graph is going down. That is an exponential decay. When I look at this table, from -3 to 3, I'm starting up at 8, and then I have 4, 2, 1, so 8, 4, 2, 1, 0.5, 0.25, 0.125. And how did I get those numbers? If I did it algebraically, I would have 1/2 to the negative 3, 1/2 to the negative 2. I'm plugging these values for x, these values in for x right there. So if you don't have a graphing calculator at home, you can still do these. Okay, so graphing these, at negative 3, I'm up at 8. Negative 2, I'm at 4. Negative 1, 2, 0, 1, 1/2, 0.25 and 0.125. So my graph is decaying. You'll know you have an exponential decay when the number, the base, is a fraction. It's a number less than 1. So growth, your base is bigger than 1. Decay, your base is less than 1. Again, this line does not go below the x-axis, so its asymptote is at the x-axis. Okay, so now we're going to take these graphs and we're going to shift them. We talked about these shifts. Hang on just a second. We talked about shifting graphs when we did quadratics. Where was the vertex? Did we move left, right, up, or down? So anytime I do something with an x, that shifts your graph horizontally. And remember, anytime you're doing something with the x value, you have to take the opposite. So if it's x plus c, you would really shift the graph to the left. If it's x minus c, you would shift the graph to the right. The d value, the number added on at the end, shifts your graph vertically, up and down. So if it's a plus in a number, you shift your graph up. If it's minus in a number, you shift your graph down. Okay? So the only one you do the opposite on is the x values. Okay, so graphing exponentials. I would really like you to be able to tell me, where does the graph go? Does it go left, right, up, or down? And then you can evaluate it either algebraically or using a graphing calculator and get the table and create the graph. Okay, so example 1. We have y equals 2 times 3 to the x minus 2 plus 1. Where does this graph shift to? I know if it has an x minus 2 here, x minus 2, you do the opposite. So really that moves the graph right 2 from 0. And this plus 1 tells me the graph is going to go up 1. Okay, so we know we're going right 2 and up 1. So if my graph is shifting right 2, when I go to look at my table, I would need positive x values versus negative x values because I went in the right direction. So typing this into the calculator, y equals 2 times 3 to the x minus 2, arrow that cursor down. I don't need 2 x's though, plus 1. So seeing how when I graph this, I need x's over in the positive direction. When I look at my table, negative 3, negative 2, negative 1, they're all towards 1. And if I keep going in a negative direction, my numbers are never going to go below 1 because there's an asymptote there. So what can I plot? Look for values in your tables that you can graph. I can graph 3 and 7. I can graph 2 and 3. So I have 3 and 7, 2 and 3, 1, 1.7, if I round that correctly. You could say 0, 1.2, and go from there. So 0, 1.2. 1, 1.7. 2 and 3, 3, 4, 5, 6, 7. And remember, when I look at the picture, this graph does not go below 1. So when I sketch this graph, I need to hover right above the 1 line. And I can draw in that asymptote. At 1, this graph will never go below it. It'll get really, really close to it, but it will never touch it. So in our table, see how if I keep going back in the negative direction, the numbers are still rounding, but I never hit 1. At -8, it looks like 1, but it's 0.0000 something. The calculator can't show you all those. Okay. So and this is an example of a growth. How did I know it was a growth? Because the base was 3. Okay, so example 2, in that same sense, if I have 0.025, I know that tells me that this graph is going to be a decay. I know that if I have x plus 1 here, if it's x plus, that moves the graph to the left one. And if I have -2 at the end, that moves my graph down 2. Okay, so let's find some points to plot. In my calculator, we have 3 times 0.25 to the x plus 1 minus 2. Here's the picture that we need to make. Remember, this graph is going down 2, so it looks like we have an asymptote at -2. If I go to my table, I can't graph any of these values, but I could graph at -2. I'm up at 10. If I keep going in that manner, at -1, 1 is a point on my graph. At 0, I have -1.25. At 1, I have -1.8. And so on from there. So -2, 10 is at the top of my graph. -1, 1. 0, -1.25. 1, -1. 0, -1.25 is underneath 1. 1, -1.8 is right above -2. And we saw from our table, the graph just keeps going. So at -2, I have an asymptote. So when we go to draw this graph in, it's going to come down quite rapidly and then flatten out. Okay. So that's graphing. Tell me the translation, figure out what the picture looks like, write down a table and plot the points. You can model exponential growth or decay with a constant percent increase or decrease over a specific time using this function. AT equals A, 1 plus or minus R to the T. So all this is saying is, this is what you're ending with. Whatever numbers here is what you're starting with. R is your rate. So if I give you a rate as a percent, remember your percents have to be written as a decimal. Okay? And then obviously T is your time. If you're growing, you're going to use plus. 1 plus 5%. 1 plus 4.2%. If you have a decay, you have to use 1 minus. You're decreasing. All right. A cup of tea contains 35 milligrams of caffeine. The average teen can eliminate approximately 12.5% of the caffeine from their system per hour. So you burn off about 12.5% of caffeine every hour. from drinking a cup of tea that has 35 milligrams in it. Did you know that tea is the second most consumed beverage in America, in the world? Water obviously is first, tea is second. And that half the population in the United States drinks tea daily. And it's found in over 80% of U.S. households. That is how popular tea is, you guys. Just thought you should know. Fun fact of the day. Okay, back to our math. Writing an exponential equation. I know a cup of tea originally contained 35 milligrams. That's what I'm starting with. I know that we can eliminate 12.5%. So 12.5% written as a decimal is 0.125, and that would be our rate. Okay, so I don't know how much we're ending with, but I do know we're starting with 35 milligrams. I know my rate is 0.125, and if we're eliminating it, we're burning off this caffeine as we go throughout the day. It's going to be a 1 minus 0.125, and I don't know the time. Does it take me 2 hours to burn off all the caffeine? 3 hours? 4 hours? Okay, so if we take 1 minus 0.125 here, our exponential equation is 35 times 0.875 to the t. Or x if you like to use x. Okay? If that's our equation, then you should be able to tell me how much caffeine is in your body 3 hours after you drink a cup of green tea. So if 3 hours is my time, I could say y equals 35 times 0.875 to the 3. Going to my calculator, 35 times 0.875 to the 3 equals 23.45 milligrams. Okay, guys, I hope you learned a little bit about exponential functions. So I will see you in class tomorrow. Bye.